Welcome back. We're on day 2 of our lesson about differential equations. We're going to do a few more problems just to solidify things for ourselves. Number 6. Find the equation of the graph that passes through 1, 1. I had to catch myself because I was ready to go point slope for them like autopilot, and then I realized it's not linear. In fact, look at the derivative. Y prime's got variables in it. That's not a line. Okay, so it is going to go through 1, 1, but that 1, 1 will be used to figure out what the plus c is, the constant of integration. First things first, I need to get things rewritten and variables separated. So y prime, of course, is the same as dy dx. I'll copy the other side as is. I immediately notice that cross-multiplying will not only get rid of fractions, which it always does, but it's also going to separate the variables. The y's and dy's will be together, and so will the x's and the dx's. So that is fantastic. All right, we're ready to go. Let's integrate. Left-hand side is going to be 9 halves y squared equals. The right-hand side, let's see, up by a power. That's going to be negative 2x squared plus c. Again, we only need one plus c on the right-hand side. That is enough to suffice. Let's get that 1, 1 plugged in up here. If you plug a 1 into the left, you're just going to end up with 9 halves, or 4.5. Plugging in on the right-hand side is just going to give you negative 2 plus c. If you add 2 to both sides, that's going to be 2 and 9 halves, which is a really weird way of saying 6.5. All right, so we're going to use that. Let's take the last equation that we had, this one right here. I'm going to bring it up top. I'll rewrite it, but instead of the plus c, we'll put a plus 13 halves there. As I typically do, I want to get the fractions out of there, so I'm going to double everything. Just multiply by 2. That'll make negative 4x squared plus 13 over here on the right. Yeah, normally I would divide everything by 9, square root both sides, so forth and so on, but some textbooks will throw you a bit of a curveball, which is really why I wanted to make this example problem. You may see certain texts go ahead and add a 4x squared to both sides. Again, there's no real right or wrong way to do this. I just wanted to show you a different look. And then suddenly they'll be like, ta-da, that's the answer. And if you recognize it from pre-calc, it's an ellipse. I know it's an ellipse because x and y are both squared, so that rules out parabola. And they have different coefficients, but the same signs. If the signs were opposite on the squares, it would be a hyperbola. If the coefficients were the same, like if they were both 9s or both 4s, it would be a perfectly round circle. Circles actually are ellipses, they just happen to be completely round. But that's an ellipse, yeah. Ellipse, not eclipse. That's science. All right, if you did go ahead and divide by 9, square root, try the 1, 1 in, that's fine as well. You would actually get the top half of the ellipse, or top portion of the ellipse. Technically, the entire ellipse still would go through the point 1, 1. So really, there's some flexibility with what teachers would be willing to accept here. I guess if, when in Rome, do as the Romans do. Ask the teacher that's grading you what their expectation is if you run into something like this. All right. Let's go ahead and do another somewhat bizarre problem. I saved all the weird ones for day 2 here. Number 7 has an equation that we call non-separable. Remember I say, hey, the first thing you have to do is separate variables. If you don't, College Board will freak out on you. Well, you can't do that here. Sure, I can bring the dx over to the right, and I should, and I will. But you can't divide by the 6y because you've got the minus 4x there. Oh, man, there's just no way to get the y's on the left without bringing x's along for the right or without having 4x over 6y. It's just a mess. This can't be separated, which means it can't be solved. Why would I give you a problem that can't be solved? And I'll tell you, College Board has been doing this too recently. They give you differential equations that can't be solved like this. What the heck? Well, notice I'm not asking you to solve it. I'm simply saying, hey, does the original function, which we can't find, have a relative min, max, or neither at x equals 9? And explain why. Justify your answer, which means write a sentence. At least one. Okay, so we can't solve it, but we need to know if it has a max, min, or neither at 9. Great. All right, I'll tell you what. Let me back up. Since I can't solve it, I won't try to. So I'll go back to the original. But I also noticed that if x is 9, then y is 6. It's the point 9 comma 6 that we're talking about. So let's try 9, 6 in. X is 9. Y is 6. dy dx is going to be, let's see, 6 times 6 minus 4 times 9. Oh, that's 36 minus 36. That is 0. So dy dx is 0. Now, of course, that could be a max, because the slope right at the max is 0. It still could be a min. Those are very much alive. Obviously, if the slope had come out something other than 0, those would be eliminated already. So max and min have a better chance at being right, but so does neither. I mean, you could have something with a little ripple and a point of inflection in it, and the slope is temporarily 0 right there, and that's not a max or a min, so we still really don't know, but that's helpful. The way to break the tie, the second derivative test. So let's find a second derivative, and that is able to be done. I'm going to show my work right over here. Second derivative. Again, weird notation. I am not the inventor of that. The derivative of 6y is going to be 6. Oop, that's the wrong letter. dy dx. Oh, a little implicit differentiation. Okay, minus 4, and x is the proper letter, so that's cool. Now, I don't have to substitute the 6y minus 4x into the parentheses. I don't have to do any of that, because remember, we're still at the point 96, and I know that dy dx there is 0, because we found that out over here. So really, the second derivative there is just 6 times 0 minus 4, which of course is negative 4. And if the second derivative is negative, we're going to be concave down like a frown. So it's going to be this situation right here. And this 0.96 is a relative maximum. All right, I just have to justify my answer. I have to write a sentence. And the sentence I'm going to write, and you'll see it in a moment, is this. The first derivative was 0, and the second derivative was negative. Therefore, the 0.96 is a relative maximum. That's all you have to say. All right, that's a great explanation. It's a great justification. Really, you're using the second derivative test. You don't have to say it by name. Graders will love you. All right, let's try another. Again, you can see that this differential equation is non-separable because I see the subtraction sign in it. There's no way to separate variables, so I can't ask you to solve it, and I don't. I do the same thing as number 7, max, min, neither, at the point negative 1/8. Justify your answer. Well, first and foremost, we try the negative 1/8 in. If it makes the derivative anything other than 0, then max and min have been eliminated, and it's got to be neither. I have a feeling, though, being the author of this problem, that, let's see, 6 times negative 1 squared, that'll be 6 times 1, minus 3/4 of 8. Yeah, that's 6 minus 6. So the derivative is 0, which means all three choices are still very much alive. Although I think max and min have a better chance, generally, on this kind of problem. All right, let's take the second derivative to break this three-way struggle. All right, the derivative of 6x squared, of course, is 12x. And the derivative of negative 3/4 y is negative 3/4. Oop, that's the wrong letter. dy dx. I'm not even going to write dy dx, because you know what? I know it's 0. Let's just put the 0 in right now and just be done with this. So that's going to be a whole bunch of nothing. Second derivative is just going to be 12 times, wait for it, here it comes, -1. That's -12. So let me get this straight. The first derivative is 0. The second derivative is negative. Again, that's concave down. Just like the last problem, it's going to be another max. Bet you a lot of you thought I was going to change it up. I went 2 maxes in a row on you, but don't worry, there'll be plenty of mins in your life. Mathematical and otherwise. It's okay. It's all right. We'll get through it. On the brighter side of things, I was just able to shamelessly copy, cut, and paste my last answer from number 7 and just change the numbers around a little bit. And we have a winner. All right, one more problem to go, number 9, and that'll wrap up 2 days of Diff-EQs. Here goes. All right, we're ending with a bit of a challenge, which is all right. We want to find the limit as x approaches 1 of that large fraction. Since we're finding a limit, that means the answer's not going to be max, min, neither. It's going to be some number. Perhaps a fraction or a decimal even. All right. Let y equals f of x be the particular solution to that Diff-EQ. The original condition means that the original graph goes through the point 1, 6. I'm going to write that as a point like I like to. I'm going to make note of the equation just so I can find it easily. Okay, let's do this. I'll do it in a different color. Let's go with some blue. Okay, find the limit as x approaches 1. Whenever we did limits in chapter 1, I said go ahead and try just to shove the number in right away. You can see this is going to fail miserably, however, because we're going to be dividing by 0. And worse yet, when you put the 1 in here, f of 1 happens to be 6. Remember, f of x is the same as y. So 6 minus 6, you're going to have 0 over 0, which is indeterminate. Now, luckily, we learned about L'Hopital's rule ahead of time. My textbook I teach out of it has it in chapter 8, but I've taught it already. And we can use it here, and we'll need to. All right, so let me get rid of the blue, and we're going to try to start over. That didn't go so well, but 0 over 0 tells me that L'Hopital or L'Hospital's rule, we're eligible to use it. If it's 0 over 0 or infinity over infinity, it's game on. All right, so let's go. Let's try it. So L'Hopital's rule says you have to take the limit still. You have to write lim. X approaches 1. But this time you're allowed to take the derivative of the numerator and denominator separately. It's not quotient rule. The derivative of f of x, of course, is f prime of x. And the minus 6 falls by the wayside. In the denominator, we use the power rule, so you got 2 times 4, that's going to be 8. X minus 1 to the first. All right, that looks pretty good. Let's go ahead and we'll plug in the 1. But the denominator is still 8 times 0, which is 0. That's not cool. Let's see what the numerator is. You plug the 1 in. F prime of 1. Well, f prime is the derivative. dy dx up there in red in the box is also the derivative. I can put the 1 there. But remember that y is 6, not 1. It goes through the point 1, 6 over here. So that's going to be 3 minus 3. Dang it, it's still 0 over 0. So I'm not done yet. But I can do L'Hopital's rule again. I mean, after all, what if the blue was the original problem instead of the black? L'Hopital's rule should work. All right, let's try it again. Remember, we have to write limit as x approaches 1. If you don't write that, they don't give you credit. Neither will I. Okay, the derivative up top is going to be f double prime of 1. Down here, this is really 8x minus 8, so the derivative of 8x minus 8 is simply 8. Well, hey, we're not going to get another 0 over 0, at least, thank goodness. That's great news. It's going to be something over 8. And to find that something, we have to take the second derivative and then plug in a 1. More than likely, the second derivative is going to have x's and y's both, so we're going to be plugging in a 1 and a 6. We have to find the second derivative. That's okay, we've been here before. Let's go ahead and just grab the first derivative, come down with it. We'll put the second derivative right here. The derivative of 3x squared is 6x. Minus 1/2. Whoop, that's the wrong letter. dy dx. Okay, now remember, we're still at the point 1,6. We've already seen that at the point 1,6, the derivative was 0, right? We tried it in earlier. We got 3 minus 3. Okay, so still plugging that in is going to make this parentheses a 0, meaning the negative 1/2 won't matter either. It's simply going to be 6x, which is 6 times 1, which is 6. And the answer is 6/8, which hopefully for me you'll reduce to 3/4. By the way, on a free response question, you don't have to reduce anything. You can call it 60/80ths and they'll give you full credit. But I'll reduce it for you. 3/4. And, ladies and gentlemen, that concludes day number 2 of differential equations. We got through it. Fantastic work. And we'll see you next time. Have a good one, everybody. Take care.